All right, systems of equations and inequalities review. So let's take a look at these problems, make sure we understand how to solve them. Now, when we're talking about systems, which these first 6 are systems of equations, okay, there's 3 different methods we can use to solve them. There's substitution, okay, graphing with or without technology. In class we have the graphing calculator, so that helps, and also elimination. Okay, so on each of these 6 problems I'm going to show you the graphing and then also either elimination or substitution. So I'm kind of doing them twice for you for that part. So we look at number 1. We have y equals 2. Okay. So we already have one of our results, right? Because what we're looking for, and maybe it'll help to take a look at some of the other problems. If you look at number 14, when we're dealing with a system of equations, there's 3 types of answers, okay? You can get one solution, which graphically what we see with one solution is we see 2 lines and they have a point of intersection, okay? That intersection point is the answer we're looking for. So x and y values equal something algebraically, and we get a point. Okay, and that's what it looks like algebraically and graphically. Okay, the other thing we run into is no solution. Okay, no solution because the solution is where they intersect. If I have 2 lines that never intersect, aka parallel lines, okay, there's no solution. If I'm solving it, what I end up doing, if I do it algebraically, is I end up getting 2 numbers that don't equal each other and we lose the variables. Okay, that's what I see algebraically. Graphically we see parallel lines. Then we also have infinite solutions or many solutions. Okay, so that is when it's actually the same line and so they overlap constantly. Okay, what we see there is when we solve it using substitution or elimination, we end up getting 2 things that are equal. Okay, eventually we can get down to 0 equals 0. That's how we see it algebraically. Okay, so those are the 3 situations we have to deal with. So going back to these ones, that's what we're looking for. So number 1, we're looking to see, is there one solution? And if there is, what is it? So we know y value already is 2. So I can take that and plug that 2 in for my y value, and then I can solve for x. This is using substitution. Okay, so I could add 4, get 6 equals 3 halves x, times by 2, 12 equals 3x, because that would eliminate the dividing by 2, divide by 3, and I'd get 4 equals x. So the point 4, 2 is where they intersect. And so that means there's one solution, and that one solution is what I deem important. Now, if I were to graph this, y equals 2 is a line right there. For this one, we'd start at -4, and then up 3 to the right 2. And we see that's the point, which would make sense, right? That's the point where they intersect, which again, that's the result we're looking for. Okay, so number 2, I'm going to try graphing that one first. So we start at -2, and then we're going down 4 to the right one, or up 4 to the left one. So something like that. Okay, then +4, slope of 2x, we go up 2 to the right one, or down 2 to the left one, and I can see exactly where they're going to intersect, right? So that point of intersection is the one that matters, so at -1, 2. That's my result. Okay, now I could do this algebraically, and again, substitution would work for this one, because they're both equal to y. So I just set the x's equal to each other, right? This would go in and substitute for that y. Then we solve. add 4x to both sides. Okay, subtract 4 to both sides. Get negative 6 equals positive 6x. Divide by 6. We get negative 1 equals x, which is what we had. Then we take that, plug it back into one of these original equations for x, and solve for y. So negative 4 times 4 is a positive 4 minus 2. It's a positive 2, y equals 2, and that's what we had right there. Okay, so on both of those we had one solution. Now, if I look at number 3, okay, we can graph this one, but I should notice right off the bat their slopes are exactly the same. What happens when slopes are exactly the same is we're going to get parallel lines. Okay, because they have that movement that's the same. So parallel lines, so the answer isn't parallel, the answer is no solution. Okay, so algebraically what we're looking at, okay, is, again, I would use substitution, well, let's use elimination for this one. So with elimination, everything needs to be lined up. So lined up, x's are lined up, regular numbers. So I've got a y and a y, so if I want to get rid of y, I'd subtract those, because y minus y is 0y. Well, 4/3 minus 4/3 is going to be 0x. And then negative 2 minus negative 4 ends up being a positive 2. Well, 0y is 0, 0x is 0, plus 2, 0 plus 2 is 2. Is 0 equal to 2? It is not, and that's what it looks like when we have no solution. Okay? All right, number 4. If we graph this one, okay, now it's not in that easy to graph format, is it? But I could still graph it. And the way I would graph it in that situation is I would think about their x and y intercepts. So negative 2, if I got rid of the y, we'd have negative 2 equals 5, divided by negative 2. I'd have negative 2.5 for my x-intercept. So right there. Okay, then if I just thought about, well, what if the y got rid of the x, so the y-intercept would be 5, because y equals 5. Okay, and there would be my first line. Then, for the next one, same thing. What if I just had negative 4? X would equal 10 divided by negative 4. 10 divided by negative 4 is negative 2.5 again. So they intersect right there. But then what about if I just had my y? I'd have 2y equals 10 divided by 2, and y would equal 5. So we can see here, these guys are the exact same line when I graph them. Okay, which means my answer is infinite solutions, because they're always overlapping. Okay, now the way we see this graphically, we could do with elimination again. Okay, but notice my x's and y's aren't the same, but if I double this top, negative 2 doubled is negative 4x. 1y doubled is 2y, 5 doubled is 10. You should notice that they're the same exact thing. But if I didn't notice it, when I subtracted, negative 4 minus a negative 4 is a negative 0, which is just 0. 2 minus 2 is 0y. 10 minus 10 is 0. 0 plus 0 is 0. And guess what? Does 0 equal 0? It does. So that's the difference in infinite solutions as opposed to no solution. Okay? Whether you graph it or solve it by hand. Okay? All right, number 5. So this one is set up to work well with substitution, because that whole thing is equal to y. So I'd plug in that whole piece for y. And again, I'm showing you multiple ways, but you can always decide which way you want to do it. Okay, it's up to you. So using substitution, we come up with this. So then I would distribute, get 16x minus 32 equals 13. add 32 to both sides, give us 45 is equal to negative x and 16x, be a positive 15x divided by 15, and x would equal 3. Then I plug that back into that equation, and it doesn't matter which equation you use. Regardless of which one I use, it's going to get the same. So y equals 4 times 3, which is 12, minus 8, which is 4. So y equals 4, so my point of intersection is 3, 4. Now, that was substitution. So now using graphing, okay, we'd go to negative 8, which is 6, 7, 8 down here. Go up 4 to the right 1, up 4 to the right 1. We get our line looking something like that. And for the second, okay, I could turn this into slope-intercept form by adding x. 4y equals x plus 13. Divide by 4, I'd get y equals 1/4 x. And then 13 divided by 4 would be what? 3 1/4, 3.25. Okay, so 3.25 would be roughly there. We'd go up 1 to the right 4. Okay, so this is the problem where graphing by hand, we run into some issues because it's hard to estimate what that is going to be. So that's when it's useful to graph by hand, or graph using our graphing calculator, right? So if I use my graphing calculator and type these in, and if you're not sure how to do that, you need to come talk to me in class so we can see. So when we graph it, we see that the 0.34, which is what we had already found out, is the solution to this system of equations, x value of 3, y value of 4. All right, now that last one, okay, it's set up really well to work with elimination because we've got a positive y and a negative y, so if I add those, that'll eliminate the y's. 0 plus 22 is 22. Negative 2x plus negative 9x, negative 11x. So we get negative 11x equals 22. Divide by negative 11, x equals negative 2. Take one of these equations, plug that in for x, and we solve. Positive 4 plus y equals 0. Minus 4, y would equal negative 4. So, should intersect at negative 2, negative 4. All right, so if I graphed these, I could change this into slope-intercept form as one way to graph. So I'd get y equals 2x, which means start out at the origin, 0, 0, up 2 to the right 1, or down 2 to the left 1. There's my first equation. Then my second one, we could do the same exact thing, or we could think, well, if I only had the y value, it would be clear up at 22, right? So it'd be way up over here. Okay, now, do I know where they're going to intersect? Yeah, at negative 2, negative 4. Then if I only had my x, negative 9x would equal 22, divided by negative 9, and x intercept would be a negative, whatever 22 divided by 9 is, 2.4, negative. So, but if I graphed that, oh, it was a negative y equals 22, so it should have been negative 22, clear down here. Okay, so sometimes graphing by hand isn't the best option, but again, using that technology, we can graph it and figure it out as well, which we can see here, negative 2, negative 4. So there are some situations that are set up to work better without graphing by hand, but work pretty fine if you're using that technology. All right, so now let's talk about some inequalities. Okay, so number 7 is a system of inequalities. Okay, now if we're just graphing one inequality, okay, we're just going to do it once. A system of inequalities. So let's look at number 8 first. Okay, if I was just talking about one of these inequalities, so say just this top one, y is greater than negative 2/3 x plus 1. Again, I can use technology to do that, or I can do it by hand. Down 2 and to the right 3. Okay, but I've got to remember that with inequalities, you're going to either have a solid or a dotted line, kind of that we can see here and here. If it doesn't have an equal to, it's a dotted line. So this one's a dotted line. Okay, then we also have to figure out, do we shade above the line or below the line? Well, it's y is greater than, so that means we're going to shade above here. Okay, now if we were only doing one inequality, that would be our answer. And our solution is in this shaded zone. Okay, but when we're doing two, we graph the second one on the same coordinate, down 2 to the right one, or up 2 to the left one. Again, another dotted line, and y is greater, so again we're shading. So the result is where they overlap their shading. So we can see this blue dotted line then goes to the orange dotted line, and this gray area is where we overlap. That's where the solution is. So looking back at number 7, our solution is anywhere in that grayed out area. So we'll call that A. A non-solution would be this area. This portion is a solution just to the red. This portion a solution just to the blue. But this portion is where there definitely is no solution at all. So there we go. Okay, so number 9 and number 10. Okay, we can graph these by hand or electronically as well. If we're doing it electronically, the thing you have to remember is how to turn it into an inequality instead of an equal sign. Okay, but graphing by hand, we get up 1 to the right 3, or down 1 to the left 3. Again, no equal to, so dotted line. The second one, negative 3 to start off, up 2 to the right 1, or down to the left 1. This one has a line under it, so it's a solid line. Y is greater, so we shade above, and y is also greater, so both of them shade above. So again, where they overlap is right here, and that's our solution. Okay, number 10. Now this one's in not slope intercept form, so it's harder to graph, but you can still do it. The way to think about it is to kind of set it up separately and do x and y intercepts. So 2x is greater than negative 2 if I got rid of the y, right? Divide by 2, and you get x is greater than negative 1. So negative 1, and x is greater, so we're going to shade that direction. Then the second part, negative y is greater than negative 2. That's if we got rid of the 2x. Divide by negative 1. Dividing by a negative in an inequality changes the inequality, and I'd get y is less than 2. So on the y-axis, positive 2. It's less than, so I'd be shading down. Now to draw the line, it would be a dotted line passing through those 2 points, and it would look like that. Okay, and we already kind of talked about where we're shading, what direction, so I know I shade this way. Okay, second one, we do the same exact thing. So what if I got rid of the y? I'd have x is less than or equal to 2. And I get rid of it because it would be 0. Because on an x-intercept, it would be 0. So x is less than, so we're shading that way. Then if we got rid of the x, it would be negative 2y is less than or equal to 2 divided by negative 2. Y would then be greater than or equal to negative 1. So negative 1, shade above. It's a solid line. Connect the line and then shade above. And again, where do they overlap? In this little slice right here. So that would be my solution. And again, if we didn't want to do it by hand, we can graph it we can see that dotted line. Their green one represents my red one. See how we shaded in the correct direction. Then the orange one is like our green one. Notice it's a solid line here, shaded above, and again, where they overlap is where our solution would be. Okay? Now let's take a look at this story problem. So, okay, the school that Gabriella goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 2 adult tickets and 7 child tickets for a total of $43. So write 2 adult tickets, 7 child tickets, for a total of 43. Okay, then the school took in 39 on the second day by selling 1 adult ticket and 7 children tickets again. What is the price each of 1 adult ticket and 1 child ticket? Okay, so we look at it this way. You can try to figure it out with just the pictures. You could use these to make an equation. Because I know the cost of an adult ticket, for the first one, I bought 2 of them. So I'd go 2 times the cost of an adult ticket, 7 times the cost of a child ticket, and that was $43. Then the second day, 1 adult ticket and 7 children's tickets was $39. And I could do it through elimination or any way. I could think about this and realize, notice that that's the same, and all the children's tickets are the same. The difference here is $4. So with 1 adult ticket left over, I know that that's going to be $4. Okay, so an adult ticket is $4. Then I could recognize, okay, if this were $4, I'd subtract it from 39 to get 35, and there's 7 child tickets for 35. Divide 35 by 7, and we get the child ticket as $5. Okay, so I could solve it that way. I could also use elimination, and I would end up with the same thing. And then plug it back into my equation, and I could even do the other equation. And I would end up with the same exact result. Okay. I could have also graph it. To graph it, I've got 2 equations. However, I'm going to have to change the adult tickets to X, and the child tickets to Y, and then I can put it in a calculator. And when I do the graph, I recognize that there's my equations, graph it so they intersect at 4, 5. Then I just have to recognize that my X was the adult tickets and the Y was the child tickets. All right? Okay, number 12. Farmer noticed that his chickens were loose and were running around with the cows in the cow pen. He quickly counted 100 heads and 270 legs. How many chickens does he have and how many cows? Okay. We could talk about the logistics of this all day, but let's just solve the problem. Okay. So, looking at this, 100 heads. Well, each chicken has 1 head and each cow has 1 head. So the number of chickens, okay, for sake of they're both starting with C, I'm just going to use X and Y. So the number of chickens plus the number of cows has to equal 100, doesn't it? Okay. Then for legs, every chicken I know is going to have 2 legs. Every cow, 4 legs. And that's going to equal 270. Okay. Now, a few different ways that I can try to deal with this. Again, you can draw the pictures. 1 chicken, 1 cow for 100. 2 with the amount of chickens. 4 with the amount of cows. Equal 270. Say, okay, I can cross off a chicken and a cow. And then subtract 100, and that would give me 170 left, right? Because those would be the same amount. Well, I can cross it off a second time, subtract 100 a second time, and then I've got 2 sets of cows for 70, so divide that in half, and I know each group of cow would be 35. So there's 35 cows. Okay, and if I know there's 35 cows, then I subtract it from 100, and that tells me there's 65 chickens. Okay, so, or I can again take the, I can graph it, or I can do elimination or even substitution. Okay, if I were to do elimination, notice I'd need to double everything here to get it to work, because then when I subtract, I'd end up with 0x minus 2y equals negative 70. Divide by negative 2 and I get y equals positive 35. Then x plus 35 would equal 100. Subtract 35, x would equal 65. Okay? Or again, we can just graph it. So I graph it and I get that. The thing I have to notice here is that I get 65 and 35, so which one means what? Well, remember x was for chickens, and y was for cows. Okay? Notice that I had to zoom out to make this work because the numbers got so high. Okay? Okay, number 13. Fernando and Melina are both members of Vasa Fitness. They each chose different plans. When they signed up, Fernando was bragging to Melina that he would soon be much stronger because his plan included a personal trainer. Fernando pays $10 a month for his membership and then $5 for every session with a trainer. Melina and her friends all signed up together, so they work with a trainer in a group setting. So her membership cost is $5 a month, with each training session costing $6. Who made the better deal for their gym membership? Which would you choose? And make sure an apparently typo on the wood. Now, so let's think about this. So what I would like to do is make some sort of table. I think that's an easy way. You could also graph it. You could also create an equation, right? For Fernando, okay, so his membership, if he doesn't meet with his trainer at all, he still paid $10, right? So number of times with trainer, cost. So in a month, if he met with them once, that would be $5 more twice, $5 more 3 times. So if he did it 3 times, right, or 4, 5, 6, 7, 8, okay, 25, 30, 35, 40, 45, and 50. Now for Melina, same idea. So if she didn't meet with her trainer, right, it would only be $5. And then it would be $6 for the amount of times. So then it'd be 11, 17, 23, 29, 35, 41, 47, and 53. So what we should notice here is if they meet with their trainer 5 times, okay, that's where they intersect, right? So, which gym membership is cheaper? Well, it depends, doesn't it? Okay, so if you're only going to meet with your trainer 5 or less times, right, then Fernando is better. Or wait, no, not Fernando, then Melina, mixing it up, is better. If you're meeting 5 or more times, then Fernando is cheaper, is better, cheaper, whatever you want to say, okay? Depending on which route you go. So, if you were to make an equation, right, Melina's equation would be y equals 5 plus 6x. Fernando's would be y equals 10 plus 5x. And then you could graph them, and you'd find that they intersect at that point, right? Okay. Then where would you choose? Pick which one you want. Do you like to go to the gym a lot? Would you work out more? Whose would you use? Okay. So this kind of depends on what you think. All right. Okay. So last one, bonus question. Albert, Grong, and Herman have decided to look at getting new phones. There are 3 plans that are available. Okay. Now, I'm almost running out of time, so I'm going to kind of be quick on this. So the first one is just $120 a month, flat fee. So Albert would be y equals 120. Okay. Grong has a different one, and he goes for $100 a month plus 2 per gigabyte of data used in the month. So we get y equals 100 plus 2x, where x represents the number of data usage. And then finally, Herman goes with the third option, and this one's a little more complex. So 4 gigabytes of data is covered. After that, it's 15 per gig. So looking at the last Herman, okay, We have to take into account that extra 4 gigs of data. We end up with an equation, a table. Here's what it looks like when we graph. So at 10 gigs, they're the same.